Hey guys, Mr. Milton here. Today we're going to look at multiplication properties of exponents. At the end of this video, you should be able to accurately use multiplication properties of exponents to simplify exponential expressions. Okay, let's dig into our concept by rewriting this expression. We have 3 to the 4th times 3 to the 5th. Okay, 3 to the 4th power would be 3 times 3 times 3 times 3. 3 to the 5th power would be 3 times 3 times 3 times 3 times 3. Right? 4 threes, 5 threes here. So basically, this is 9 threes multiplied together. So another way of writing this, 3 to the 4th times 3 to the 5th, is 3 to the 9th power. Okay? It's a shortcut. Let's see what that is. 3. How do I do that? To the, I don't want to do that there. Let me get a better calculator. Nope, better calculator. There we go. 3 to the, nope. I thought I had 3 in there. 3 to the 9th. There we go. 19,683. 3 to the 9th. Okay. So here's our property. If we're multiplying two exponents with the same base, then we can just add the exponents. Okay, but the bases must be the same to use this property. And the operation between the two expressions must be multiplication. Multiplication. Okay, so if this question was 3 to the 4th plus 3 to the 5th, we couldn't say it's 3 to the 9th, right? Because it only works with multiplication. All right, so let's go through some examples. Very simple shortcut, I guess. So we have h to the 5th times h to the 2nd. Since these are both h's, I can say h to the 5 plus 2. This is h to the 7th power. For number 2, I know I have a negative exponent, but I have 2 to the 7th plus negative 3 or minus 3. And so that gives me 2 to the 4th. Let's make that a clear exponent. Okay, I don't want to leave my answer as 2 to the 4th though. Okay, 2 to the 4th is 2 times 2 times 2 times 2. It's 16. When you can, you should write it as your simplified answer. B to the 4th and C to the 7th, you see that these are not the same basis. This is a B, this is a C. So we cannot say BC to the 11th or CB to the 11th or anything like that. This is B to the 4th, C to the 7th. This is as simplified as that expression gets until we know what any values are. Number 4, we have 3 M bases, negative 9, 5, negative 2. Okay. But they're all multiplication, so we can put them together. That gives us negative 4, negative 6. It gives us m to the negative 6. But remember, in our final answer, we should not have a negative exponent, so I'm going to make it happy by moving it to the denominator. 1 over m to the 6th. Number 5, we have 6 to the 8th and 6 to the negative 8th, so that's 8 and negative 8 gives us 6 to the 0 power. Remember, in our final answer, we should not have a 0. And so anything to the 0 power is 1. Remember that this works the same with a variable. If this were b to the 0 power, we would know that that's 1 as well. Okay. Number 6, we have p to the 8th power plus p to the 3rd power. Notice that this is addition. And so because it's addition, we can't use our rule of just adding our exponents. So as simplified as we can make it, these aren't the same. P to the 8th plus P to the 3rd. Okay, if it was P to the 8th plus P to the 8th, maybe we could say 2P to the 8th, but it's not. All right, number 7 starts to get a little bit more complicated because now we add some coefficients, but I like to just reorder my problem and like we did with our multiplication in our first section, multiply what you can together. I know that 2 and 3 can multiply together. I know that n to the 5th and n to the negative 2nd can multiply together. 2 times 3, 6. n to the third. That's how we should come out with this answer. Number 8, 6 times 3 times 2, right? All my coefficients together. Y to the third times y to the fourth times y. This is a tricky one, actually. 6 times 3 is 18, times 2 is 36. The numbers aren't tricky. Here, with the y's, notice that there's no exponent written by y, and a lot of people will just say, okay, y to the 7th, because 3 plus 4. But when there's no exponent written, the exponent's 1. It's like we assume that it's a positive 1 unless something else changes, okay? So we have 3 plus 4 plus 1, y to the 8th. Number 9, we have c to the 4th and c to the negative 8th and d to the 3rd. So c to the 4th minus 8, d to the 3rd. Okay, as we look at this, we put these two together, these two c's together because they have the same base. That gives us c to the negative 4th, d to the 3rd. We know that we can't have a negative in our final answer, so we'll move it to the denominator to make it happy. D to the 3rd up top, c to the 4th. D to the 3rd over c to the 4th. Number 10, again, reorganizing this problem to make it easier. Put together, 2 times 7 is 14, times 3 is 42. M to the 7th, P to the 5th. Number 11, 5 times 2 times 3. Again, organizing these. And it doesn't matter that, hey, this 7 was by a P and this 2 is by an M. Can we put them together? Yeah, we can multiply numbers. Okay, y to the 4th, we have x to the 1st and x to the 8th. And so I have 30, x to the 9th, y to the 4th. Number 12, notice here that this k didn't have a number by it, but it's k1 minus 3, k to the negative 2, n to the negative 7th, n to the 4th, that gives us n to the negative 3. Negative exponents aren't happy there, let's make them happy. And so I have n to the 3rd over k squared. All right, moving to the next page, doing some multiplication here. Just like we did on this other side, so I know you might be like, oh, how is this related? These don't have. Now we're going to go back to some scientific notation. Here's what we do. Multiply what you know how to multiply. Multiply the a values. In this case, we have 2.5 and 6. Then we have the same bases, 10 to the 8th and 10 to the 3rd, both 10 bases. So we can add the exponents. And then after we're done with that, make our number in scientific notation. So as I rewrite this problem, I'd say 2.5 times 6, 10 to the 8th plus 3. Okay, that gives me, what is that? 15. Oops, I'll write that here. Times 10 to the 11th. Okay, right now this isn't in scientific notation, so I want to change that and say, okay, I need to make a greater than 1 and less than 10. So 1.5, I made this number smaller, I need to make this number larger. Times 10 to the 12th. Okay, try that on the second one. We have 9 times 7, 10 to the negative 6 plus 2. So we have 63. Oops, keep writing it down too low. 63 times 10 to the negative 4th. Okay, needs to be in scientific notation, so I'm going to move this to the left. Makes it 6.3 times 10 to the negative 3rd. Now, you might say, well, can we have negative exponents? In scientific notation, we can have negative exponents. That is the only time. And then finally, challenge problem. So try it out. It says evaluate. For m is negative 4, n is 2. Remember that when we are evaluating, what we want to do is we want to simplify the expression first, then plug in the numbers, and then simplify it. So I'm going to say negative 3 times 2 times 5, m to the 4th minus 6 n to the 3rd. Okay, so as I plug these numbers in, that gives me negative 30 m to the negative second power into the third. As I rewrite this, we cannot have negative exponents. So I have 30 into the third, sorry, negative 30 into the third over m squared. Okay, remember that we can have a negative number. We cannot have a negative exponent. So this is okay. Negative numbers okay. Negative exponents not okay. So now I plug in my values. Negative 30, 2 to the third over negative 4 squared. Okay, so negative 30 times 8, that's 2 to the third. Negative 4 squared gives us 16. And so, what is that? Negative 240 divided by 16. Do a calculator with that. 240 divided by 16 is 15. So this is negative 15. There we go. All that for a regular number. All right, and so that is our multiplication properties of exponents. Number 1, we'll add to that. All right, see ya.